Good evening, students. I welcome you. Last time we had a very good and interesting session as large number of questions were answered by you students, which proved that you have got good amount of learning. The chapter which we are doing is very important. The structure of the atom, science students. And as I said, what we have learned, student, what we have learned up to now, that everything about 200 years back, 1803 to 2020, you are, and you see how the discovery of atom first proposed Dalton's atomic theory in 1803, students, when he said that matter is made up of very small and tiny particles, which is atoms. And you know that every matter is made up of small particles, atoms, students. We, our body has trillions and trillions of small atoms of which we are made up of. And interesting thing is that when we talk of element, student, each element has its own atom. Each element has a different atom because each element is different from the other element, student. So when I say carbon is an element, it has an atom, and that atom must be different from the atom of hydrogen, the atom of oxygen, the atom of fluorine, the atom of argon, or any other atom of iron, atom of iron, copper. What we try to say that Dalton's proposal was very good at that time, that there are atoms, but same atom will have the same properties, same mass, and different atoms will have the different mass, students. And then at that time he said that atoms are not divisible. But what happened after that, students? What happened after that? As in science, students, experiments are the most important thing. And as we do experiments, we will need equipment, we will need apparatus, we will need machines to do the experiment, students. So we'll need help of large number of other people who can make those machines. And then we start doing experiments. And without experiments, also a lot of evidence is available that matter has electrical nature. You know that you have told that you rub a comb with your hair, student, and small pieces of paper sticks to it. This proved that there is some charge in the matter. There is a charge transfer from my hair to the comb, and that is attracting small pieces of paper, student. All these observations are very important. Observations, activities are very important, which activities we do, student, and then we try to explain them. Then we use experiments. And you know that who was a scientist, student, who discovered electron? Fast, 30 seconds. 30 seconds for the answer, students. You already know. Who was the scientist who discovered electron, students?
Sir Thompson.
That's the correct answer. We are all interacting, students. Our sessions are live. Our sessions are interactive. Your participation is very important to learn the things which we want to learn. And we are always saying keep your energy levels high in order to learn. Pay attention, that is the point, students. Learning science means pay attention to each and every word, because every word has a meaning, every word speaks. The word itself will tell us what it means. Therefore, students, we discovered the electrons. The discovery of electron is very important. Then what happened after that? Charge of the electron was determined. Mass of the electron was determined. After that, which other particle is discovered, student, and by whom? Tell me what other particle is discovered. You are saying electron discovered. What was a subatomic particle after that? What we are talking about? Which one? This is negatively charged. What other particle? Give me the name of the other particles, subatomic particles, which are present inside the atom, student. 30 seconds. 30 seconds for answering the question. Fast. What other subatomic particles are present inside the atom, students? Tell me. Anya, name the subatomic particles present in the atom.
Sir Protons.
Yes.
Discovered by Rutherford.
Protons, and then Which other particle?
Sir, neutrons.
Yes. Protons, neutrons, and electrons. Okay, these are the three particles. Canal rays, you know, and you know that in your television, you are which rays are used in the television. Students, you know which rays, what is being used in the TV? What cathode rays? Cathode ray tubes are are used in the television screens. So, students, then three subatomic particles are there. How many? Three. And where is the mass of the atom present? Almost all the mass of the atom is present where, students? Another question for you. Jaldi, 30 seconds. Where is the mass of the atom present? Students, what is the mass of the atom due to? Fast.
Sir, nucleus.
Nucleus is the correct answer because nucleus contains what are the particles which are present inside the nucleus, students? Fast. What are the particles which are present inside the nucleus?
Sir, protons.
And
Neutrons.
that is the correct answer. Inside the nucleus, if this is my nucleus, student, you have inside the nucleus, this is positively charged. This you have protons and neutrons, and electrons are outside the nucleus. And what is the size of the nucleus? What is the size, or what they talk of the radius or diameter of the nucleus? Is very, very small as compared to atom. Approximately what are the dimensions? What if I say the size of the atom is 10 minus 10 meter, then what is the size of the nucleus, students? This is the atomic radius. This is the diameter of an atom, supposing. Then what is the diameter of the nucleus? 10 minus 15 meter. Nucleus. See, the radius of nucleus is very, very small. That means most of the space in atom is empty. That's what you are saying. So electrons are outside the nucleus, and then the model which was proposed, what models have been proposed? Can you name the different atomic models? Different atomic models, students, which have been proposed. Different atomic models. Fast, students, 30 seconds. How many models were there? Give me chronological order of the different atomic model. First model was given by whom, students? The first atomic model was proposed by fast. The first atomic model was proposed by, students. Tell me name of the scientist. Thomson. And
Sir,
after that,
discovery of electron by J.J. Thomson.
yes, I'm saying
Then,
that atomic model, first atomic model was given by whom? Thomson.
so Thomson's model of atom.
Yes, after that, there were drawbacks
Sir,
in this.
Rutherford's model of atom.
Yes, Rutherford model of the atom. After that,
So okay.
very good answer, very brilliant answer given by the Vidi. Bohr's atomic model. And later on, you will see there will be something more than Bohr's atomic model, which we will learn in higher classes. Anyway, so then you said to me, students, you are participating with me, you are talking with me, you are answering questions, you are interacting, students. Then what was the distribution of electrons around the nucleus given by whom? Who gave the distribution of electrons in the different shells, different orbits around the nucleus? Tell me what name, what is that? What are the rules? By whom? By whom the rules were given for the distribution of electrons in different orbits around the nucleus, students? Fast. 30-second time. Your time starts now. The rules were given by whom?
Sir, Bohr.
And Bohr and Bury. You in the book,
Yes.
you will say Bohr and Bury. They were the two scientists. What they said? What are the two important points about Bohr and Bury? 30 seconds for this question, students. Bohr and Bury. What are the main rules given by Bohr for filling up of the electrons in the different orbits around the nucleus? Students, what they said? How will you
Sir,
describe?
that the maximum number of electrons present in a
Uh-huh.
particular shell is calculated by the formula 2n square.
Yes, maximum electrons, okay, which can be put in any orbit or shell is 2n square and can be 1, 2, 3, and first shell is k, l, m, and so on. Correct answer, correct answer.
And
Okay.
sir, that the maximum capacity to hold electrons in the outermost shell is 8.
A correct answer, very good. Why that is correct? Because that is what we call as octet rule, students. Octet rule. Because octet means stable. But the atoms or the you know already atoms which have 8 electrons in their outer motion, they are very stable inert in noble gas elements, helium, neon, argon, krypton. Their outermost shell is filled, they are very stable, students. So that is very good answer. Anything else? First the electrons will go in the lower energy, then they will go to higher energy. That is the correct answer. Then students, what is the valency? What is the valency, students? What do you mean by valency, student? What do you mean by valency? Tell me 30.
So,
Yes.
it is the ability of an atom to gain or lose electron in order to achieve the noble gas configuration.
Okay, so good. I mean, you people are so intelligent. I can't believe. And valency is a combining capacity of the element, which depends on how many, whether how the element will achieve octet. Because octet means stability, and that is what the octet rule says. The elements which their outermost shell is completely filled, they will either gain or lose or share the electrons. That's what you are saying. Correct answer. So, students, valency is also known to you. Then tell me what is atomic number, students? What is atomic number? What is atomic number? Is represented by Z.
So,
Yes.
the number of protons in the nucleus of an atom, which is characteristic of a chemical element and determines its place in the periodic table, is known as atomic number.
Yes, absolutely brilliant answer given by Vidhi. So that is a very good answer, correct answer, and more than what is written in your NCRT ninth class. So you are very good. That means each element has its own atomic number. That depends on number of protons which are present inside the nucleus. Very good answer. For a neutral atom, what will happen? Number of protons will be equal to what? Atom is neutral. Atom is a neutral, students. Then what will be the number of protons equal to? Z is equal to number of protons. What it will be equal to? Tell me. 30 seconds. The number of protons must be equal to, for a neutral atom, student, equal to what? What should I write here? Number of protons should be equal to number of, you know it.
Of number of electrons.
Yes. The number of protons must be equal to number of electrons. Then only the atom will be neutral, student. Equal positive charge and equal negative charge. That is why the atom is neutral. Otherwise, it will become charged. And if it becomes charged, then what will be? There will be a real trouble because charged particles are not stable. They will react. You know about it. Atom is stable, matter which we are using is stable, student. If atom is not stable, the matter we are using cannot exist. My body cannot exist if my atoms are not stable. I will dissolve, you will dissolve, the universe will also dissolve. So that is important point, students. Okay, so we have started understanding the mysteries of the nature, the existence of the matter on the universe, student. All right. So then what is another thing? Mass number, student. What is our mass number? What is a mass number? Students, how do you define mass number? 30 seconds are.
So,
Uh-huh.
So mass number of an atom is defined as the sum of the number of protons and number of neutrons.
Okay, correct answer. So the complete revision of what we have done. So we are so much good answers have been given by the students. That means we have understood, we have learned everything till now, students. The structure of the atom and basic things we have clearly understood. And next time we are going to have a very, very important quiz contest, students. So then there will be an amazing session is coming. So you have learned everything, you have learned everything. So today's topic is very, very important. What we are trying to say, students, all this is known to us so good, so well. So what happens, students, when you see that in nature, students, you are saying atomic number is equal to number of protons. You told me, but in the nature, student, what they found that the same element is existing in different different isotopes, which we have told you what there are elements which have the same atomic number but different mass number. Interesting that what they observed, that for example, if I take hydrogen, student, H, hydrogen has got one proton and one electron. There is no neutron, zero neutrons in hydrogen. And this hydrogen, which is the most abundant in the universe, student, I can represent. How do we represent? We have already told you how do we represent, students. X, this is my mass number. Mass number is my A. Mass number was represented by A and Z. This is a representation of an element, so I am representing it by 1h1. Okay, 1h means atomic number is 1, number of protons is 1, and number of electron is also 1. There is no neutron in the atom. There is no neutron present in the first hydrogen atom. But in the nature, they discovered what they discovered. There are hydrogen which were discovered, one H2 and one H3. What it means, students? That this is the same atomic number. Atomic number is same, but mass number is different. And what do we call these atoms? These atoms, what we call these atoms, student? Isotopes. What I am trying to say, in nature, there are three isotopes of the hydrogen. Students, which one? 1H1, 1H2, and their abundance in nature is different. Supposing this is 99.999%, this is only 0.000, and this may be 10 minus 13 or something, very, very low percentage, but it is present. They found it that these are the three isotopes, these are the three elements which are hydrogen. They have the same atomic number, students, but a different mass number. And if they have the same atomic number and different mass number, what do we call them as? These are called isotopes, students. So we are coming to another important point, student. Question is, what are isotopes? I am saying hydrogen has got three isotopes, student, and the names have been given. Say number of protons. If I say 1H2, student, tell me. I am saying, now I am asking you this question. 1H1. Tell me how many protons are there in this? How many electrons are there in this? And how many neutrons are there? First question to you, students. How will you find out? You already know. I will give you 1 minute for answering this question, students. Fast. Once you start answering the question, student, we will learn a lot of good things about science.
So
Now, yes.
number of protons are 1,
Huh?
neutrons 0, and
Yes.
electrons 1.
Okay, absolutely right. Absolutely right. Very good. Now we are on our way to answer many more questions. And we will understand isotopes so easily that you will never forget, students, you will never forget the concept of isotopes, because isotopes will always be there. Most of the elements will exist and have isotopes. Percentage may will be how much abundance is there, that is another question. Their abundance we have listed now. These abundances experimentally obtained and given in the books table. In higher classes, you will learn everything. So, okay, students. Now let me see. I'm getting some space for the isotopes. Isotopes. Such good answers have been given by all the students. So we are so happy that this chapter is mastered so well by the students. We have to keep on interacting, students, talking and answering questions. That is the way to learn, and that is my way of teaching. That my students are a part of my life. They interact with me, they talk with me, they answer my question, and they put up the questions. I also learn a lot of things from you. I also get energy from my students. Okay, so you have said 1H1. You said protons student 1, electrons 1, neutron 0. ठीक है? Another element is the same hydrogen, but we discovered in nature 1H2. Now you tell me what is the number of protons, what is the number of neutrons, and what is the number of electrons in 1H2. Tell me fast. How many protons, how many neutrons, how many electrons will be there in 1H2, students? The mass number is 2, atomic number is 1. A is my mass number. This is my mass number, student. We learned it. This is my atomic number, student. We learned it in the previous lecture. So how many protons are there? Fast. And you know mass number is equal to sum of the protons and neutrons. What is the number of protons then? Fast answer should be given. What is your answer coming? Protons how many? 1. Electron 1, neutron 1. So here you find 1 proton, 1 neutron and 1 electron. Here there is no neutron, but here you are getting 1 neutron. This is an isotope of the hydrogen. And do you know what it is known as, student? What is the name given to it? What do we call this 1H2 as? Deuterium. Deuterium, and represented by D. This is shown by D. Deuterium. Deuterium, there is a heavy water, we will tell you, D2O. H2O is what we are drinking. Inside that, there is a very small percentage of D2O also, students. And how do you make D2O? We will obtain from the water which we have, but this is a very difficult process. And very small amount is there, students. And it is very costly, D2O. We will tell you. So deuterium has how many protons? 1, neutrons 1, electrons 1. So this will be heavier. This will is going to be heavier, student, than this. The mass is 2 times. The mass is 2 times. Another isotope is discovered for the hydrogen. That is what we are saying, 1H3, students. 1H3. And what will be the number of protons, neutrons and electrons? In this case, student, we can apply the same formula. Mass number here. What is the mass number here? Mass number A. Mass number is 3. Atomic number is 1. Then you know how many protons, student? 1. Electrons 1. Then P plus N equal to 3. Proton is 1. Then neutrons will be how much? 3 minus 1, 2. So there are 1 proton, 2 neutrons and 1 electron. These are called isotopes, student. These are called isotopes. Elements which have the same atomic number but different mass number. So their chemical properties are going to be the same because they have the same number of electrons. But their physical properties will change, students. Physical property, because one is heavier than the other. One is 2 times. What do you call this? 1H3. What is the name of this, student? You are aware of it? This can be represented by, this is called tritium. Tritium, students, and can be represented by T. So we have three isotopes of the hydrogen. Can you student give me examples of some other elements which are existing in isotopes? Do you know any other element which exist in isotopes? Can you give me some other examples of elements which are existing in isotopes, students? Do you know anyone? Tell me. Okay, I will give you. Carbon has got three isotopes, student. Three isotopes are there for the carbon. This is carbon atomic number 6, mass number 14. This is a radioactive. Radioactive. What is a radioactive means, students? This is a radioactive isotope of carbon, student. Can you tell me, student, what do you mean by radioactive isotope? Radioactivity was discovered by whom? Tell me. In the book, they have mentioned radioactivity. Radioactivity, students. What was the radioactivity experiment? Did you read the book? What was written in the book? Something like radioactivity. They have told that there are certain particles, there are certain elements which emit certain radiation, students. They emit certain radiations.
So it is basically
Huh?
def- so it is basically defined um as the emission of particles and electromagnetic rays from the nucleus.
Okay, very good. That's so good. I mean, the nucleus emits certain types of rays or radiation, students. And who discovered this? You know the how the radioactivity, certain radiations were obtained from certain elements. And you know radium, you are aware of the radium. Radium is radioactive, emits radiation. Nowadays, there are so many elements, student, which are radioactive. We are aware of it. Earlier, Madam Curie's, you know, they were doing experiments and they found radium was an element which were emitting certain radiations. So radioactive isotopes. This carbon 14 is a radioactive isotope, students, important. And you know what it is used for? Can you tell me what is the use of C14 isotope? This isotope is very, very important, student. What it is? What it is used for, student? Carbon dating. It is used for carbon dating. You know what is carbon dating? Can you tell me what is carbon dating, student? You know how you find the
So
A? Uh-huh. Yes.
it is used in a breed test to detect the
Yes.
bacterias.
Actually, how do you determine the age of the old objects or old things? You are saying this tree is 2000 years old. How do you know? Our life is 100 years, supposing. Then how do we say that this tree is 2000 years? I was not there 2000 years ago. So carbon dating is a technique, student. C14 isotope is radioactive. We will determine how much of C14 is present because it keeps on decreasing. The amount of C14 is decreasing. So from that we determine the age of the old things and even those certain human bones which are there. Their age is also being determined by this method, student. This is called carbon dating. So carbon has three isotopes and the main, this is the most abundant. This is the most abundant. These are present in very, 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 very small amounts, but they do exist in the nature. Similarly, if I say chlorine, student, there are two isotopes of the chlorine, which we are writing like this. These are the two isotopes of the Cl, student, important point. So you have isotopes of chlorine. I have shown isotopes of carbon. Similarly, there are isotopes of other elements also, which are given in the book. If you want to see, you can see more large number of elements. They have their isotopes. And important point to note is, student, important point to note here is, what is the important point to note here? You are so intelligent, students. You should learn more than what is there in the books. What is important, student? When we determine the mass, mass of the elements, students. And you told me the mass of the element is due to the mainly nucleus, students, because the mass of the proton plus mass of the neutron plus mass of the electron, that is what an atom is. This is negligible, so we ignore it. You know that the mass of electron is 1 by 2000 times that of the hydrogen atom. So mass of electron is negligible. So if I don't count it, makes no difference because it's very, very small. So the mass will be mainly due to protons and neutrons. And that is why we defined mass number. That is why we defined mass number, students. And when you have seen mass number, you are told me is equal to how many number of protons plus number of neutrons, and this will be a whole number, student. There is no half proton or half neutron, so this is a whole number. When I say mass number of, if I say the mass number of carbon, so you are saying carbon has proton 6, neutron 6, so 12 mass number. You are representing carbon as a, if I represent like this is the mass number is 12. Mass number is 12. Similarly, if I say chlorine, if I write 17 Cl35, then you are saying protons 17, neutrons 18, 35 is the mass number. What is the mass number, student? P plus N, this is the mass number. But when atomic masses were determined, students, when atomic masses were determined, student, atomic masses, they found, for example, in the case of Cl, chlorine, the atomic mass is written in the book like 13.5 U. The atomic mass of Cl is written as 35.5 U. We told you U means the mass of one atom. Now why it is fraction then? Why this is coming in fractions, student? This is the question. Why you are getting not a whole number here, but fraction? Can you tell me, students, what is the reason? What is why 35 is not written, but 35.5 has been given as the mass of the chlorine atom? Why the mass of chlorine atom is 35.5? This is a question which was asked in the paper. Why the mass of Cl is written as 35.5 U? Why it is not 35 complete whole number? Can you tell me what is could be the reason? Think about it, students. You have 30 seconds. For every question, I am give you 30
So,
seconds.
so
Yes.
the reason for the atomic mass of chlorine taken as 35.5 U and not as 35 U because of the presence of the isotopes.
Okay, that is the correct answer. Very good answer given by Vidhi. You know that is what we are trying to tell you. That number of protons means atomic number, and that means the element Cl. When I say chlorine, you are saying okay, atomic number 17. This is not going to change, but number of neutrons that can vary, and when number of neutrons changes, student, you get isotopes. And we know already, students, we know in the nature there are two isotopes of chlorine. What we are saying, students, this is very important. There are two isotopes of Cl. And which are those, students? One I am saying is 17 Cl35 and other is 17 Cl37. Both are not present in equal amount in the nature. Abundance, what do you mean by abundance? Means how much percentage is present, student? How much percentage they are present? So they are not present in the same amount, student. It was found they are present in the ratio of 3:1. If out of 100, 75% is this. This is 75%. And what will be this then? How much is this left, student? 25%. Abundance. This is called abundance, means how much they are present, student. That means if I take 100 chlorine atoms, out of that 75 will be 17Cl35 and 25 will be 17Cl37. So there are two isotopes. It is not only one. If there is one, then no problem. Why will it come in 35.5? Then students, what we do, if there are more than one element with the same atomic number but different mass number, there are two, there could be more than two also, as we have shown in the case of hydrogen. Hydrogen has got three isotopes. Which one? Protium, deuterium, and tritium. We have just shown you, student. The first one, this is called protium, 1H1. This is 1H2, this is 1H3, this is 1H1. This is called, student, protium. Protium, deuterium, and tritium. Three isotopes of hydrogen. Abundance is different. So the mass value will not be 1. And it comes to be 1.008. In the books you will see. But we take it for calculations as 1. Therefore, students, this is 75% and this is 25%. In such cases, student, what we will do, we will calculate the average atomic mass. What is given in the books, student? They are not atomic masses, they are average atomic masses, because not one isotope exists. They are existing in the form of more than one isotope as for the Cl. So how do I do the calculation? How will I calculate the average atomic mass? The question is, now here I have already told you average atomic mass. Average atomic mass, this can be calculated by summing the mass of elements each multiplied by the natural abundance on the earth. So if F1, if there are, M1 is the molecular mass of one isotope, M2 mass of isotope 2. If there are more isotopes, then M3 and so on. And fraction representing F1, F2 are the fraction of the natural abundances of isotopes. Then we will calculate the average mass of the element by using this method. How do I calculate? Now the question is before us. Let us see what we are saying. I am saying, students, let me create some space here for you because you have understood this idea. How will I calculate the average atomic mass of Cl, students? What the value is given in the books, because my abundance is given to me. Abundance is given, students. How will I calculate the average? This is an important question for the exam. How to calculate the average atomic mass, student? We are taking the example of chlorine. We are taking the example of Cl. Okay. What is given, student? Question is like this, that chlorine has got two isotopes. We are saying 17Cl35 has 75% abundance and 17Cl37 has 25% abundance. Calculate average atomic mass of Cl. This is the question. How do we get the answer of this? Out of, supposing you have 100, I said supposing you have total 100 Cl, then out of 100, how many are 35? 75. So I say that 75 into 35 plus how many 37 out of 100, out of 100, I'm saying out of 100. ठीक है? How much is that? 25 into 37. And this is out of 100. If I divide these by 100 student, then what answer I will get? This will be my answer. This will be my average atomic mass of Cl. So if you will calculate, students, after doing the calculation, student, you will find that you will get 35.5 U. So that is the reason, student, atomic masses are given in fractions in the books. If you will see the atomic masses of different elements, you will find they are not whole numbers, they are in fractions. Is it clear to you, students? Any doubt? Tell me, you have any doubt up to now?
No, sir.
Okay. So the value which is given in the book is average atomic mass, because there are two isotopes of the Cl. And if I know the percentages present in the nature or natural abundance, I can calculate these values. These isotopes are of great use, student. They have great applications. Their chemical properties are same, but if I take a mixture, they have special properties because their physical properties will be different. As you can see, one is heavier than the other. For hydrogen also we have listed. For example, for the hydrogen, you have told me 1H1, 1H2, 1H3, and you know this is heavy water at D2O, heavy water, student, and this is the water which we are drinking, heavy water. This because deuterium, this is two times heavier than hydrogen. This is very important, used in nuclear reactors, very important, used in nuclear reactors, student, heavy water. Very costly, very difficult to prepare. And finds great use in nuclear reactors. You know nuclear reactors. Are you aware of nuclear reactors, student? Yes or no? What we do in nuclear reactors? You are aware of nuclear energy? Atomic energy, nuclear energy. You are aware of the nuclear reactions, atomic bombs and other hydrogen bombs. So this heavy water is of great use to us, and it is a because the isotope of the hydrogen deuterium, mass number is 2, atomic number is same. This is a heavy water, and they are of great use, students. And isotope, for example, uranium. You know uranium, student. I'm talking of applications, student. Applications of isotopes. They have asked a question on this. What are the applications of isotopes? Uranium has two isotopes, 235, 92, U238. And an isotope of uranium is used as a fuel in nuclear reactors, student. Fuel in nuclear reactors. So in the fission reaction, you will see that an isotope of uranium is used in the nuclear reactors to create energy, student, to create energy, your atomic energy. And an isotope of cobalt. As I said, there are isotope cobalt, CO, cobalt. What is the formula of CO? An isotope of cobalt is used for treatment of cancer. Treatment of cancer. The radiations emitted by the cobalt isotope are used for the treatment of cancer, student. And iodine, an isotope of iodine. Iodine also has isotopes. And an isotope of iodine, student, is used in treatment of goiter. You are aware what is goiter? Is a disease. Have you heard about goiter? Did you hear about goiter, student? Is a disease student, for that treatment we can use an isotope of iodine. Isotope of iodine. Therefore, students, they are of great use and has huge amount of applications. That is why a lot of work is being done by the scientists on isotopes. Isotopes are very important. And how do we get them? Certain isotopes are existing in very, very small amounts. Then what will we do? Then we have to use very special methods for their preparation. And we are buying it from some other countries. They may not even give us when we pay money for it, because of their great applications and uses, students. Okay, then now I am coming to another important thing which I am talking of, isobars, student. We have told you isotopes. Isotopes are those elements which have the same atomic number but different mass number. Means the number of protons is same. As you can see here, I have shown protium, deuterium, tritium. Number of protons same, one proton, one, and number of neutrons different. Can you see it? Did you see that? Carbon, I said I have isotopes. Chlorine has got isotopes. So atomic number same, mass number different. Atomic number same, mass number different. They are called isotopes. These are called isotopes. Clear? Any doubt? And now I'm saying there are isobars. What we discovered, what we find, student, atoms of different elements are there which have different atomic number but same mass number. I'm saying different atomic number. Different atomic number means they will be different elements, but mass number same. Mass number same means what, student? Sum of the protons and neutron is same. Such elements are called, student, such elements are called isobars. For example, student, what I am talking is isobar, student. For example, if I consider uh, here one example I am giving, calcium. Calcium, for example, has atomic number 20. Atomic number 20. Okay? And argon has atomic number 18. Calcium atomic number 20, argon atomic number 20. The mass number is 40. The mass number is 40. Similarly, student, if I take potassium, atomic number 90, mass number 40. What do you find in these elements, students? What is same? Tell me what is same here. Atomic number is different. 18, 19, 20. They have different atomic number, but mass number is same. You can see they have the same mass number, but different atomic number, students. Different atomic number means they have different number of protons. The number of protons cannot be same because atomic number is different, but sum of the protons and neutrons comes out to be the same, which is the mass number. Mass number is P plus N. Atomic number is equal to P. Clear? Any doubt? Tell me. Can you tell me? I have given you argon, atomic number 18, calcium 20, potassium 19, but mass number is same, 40, 40, 40. These elements are called isobars, student. Iso means same mass. Bar means same mass. Yeah? And that was isotope, student. Iso means same, top means same atomic number. They are the same atomic number, same number of protons. Isotope, same number of protons. Isotope. Iso means same. Any doubt, students? Tell me. Is there any doubt?
No, sir.
This ends your chapter of atomic structure, students. What other chapter is being done, students, in the school? What are you doing? What chapters you are doing now in the school? Which topic is done in the school nowadays? you have finished this atomic structure in the school, students?
Yes,
Okay.
sir.
Next, what they are doing in the school? They finish the course or doing something else?
Sir, actually, abhi exams the, so they were just doing the revision. So
Okay, revision.
we
We will
haven't
we will
started
take out the
anything.
revision. Next time is a session of quiz. Next time there will be a quiz session between you and me. Get prepared for the quiz and try to get 100% marks in the quiz. That session is very interesting and large number of people all over see that quiz contest. So we will have a quiz game next time, quiz contest. That topic is structure of the atom. You learned it so well. Let us see how well you are doing. Okay, bye bye. I'll see you in my next class. Thank
Thank
you
you, sir.
for answering question and giving me also energy to keep on interacting with the students. Bye bye. We'll meet you in the next class.
Thank you, sir.
Okay.